So far in the past we've just worked with, having a function, call it f of x, and then taking the derivative of that once. Sometimes people have wanted to take the derivative multiple times, but we haven't actually formally worked with that yet. What we're going to do is we're going to work with that now. So a higher order derivative, let's write this down. All it is just the derivative of a derivative. So for example, let's say we started off with f of x, and let's say f of x equaled x to the 9th. And we know that we can find the first derivative of f of x by bringing down that exponent and subtracting 1 from the exponent. Well, we don't have to stop there. We can take what's called the second derivative. Notice there are 2 little tick marks instead of 1, f double prime. And if we do that, we bring down the exponent again. That's 72x to the 7th. So this is called the first derivative. This is the second derivative. And if we want to, we can do it again. Logically enough, that's called the third derivative. There are 3 little primes right there. And we bring down the exponent, subtract 1 from the exponent again. There's our third derivative. Now, if we keep going, eventually I start just getting to be too many little tick marks. So after the third derivative, we'll actually just write it as a little tiny number. So that's the fourth derivative. And we just bring down that 6. And we can keep going until we run out of things to take the derivative of. Eventually, for most functions that are some sort of exponent of the power here, we'll eventually get down to where we have a derivative that equals 0, and at that point we basically just have to stop. We can't go any further. But if you have something like f equals sine of x or something like that, you can actually just keep taking the derivative indefinitely, because it'll just cycle around and around and around that circle. So that's all that we're really doing with this lesson, is it's just saying we take the derivative once and then we take it again. But let's first go over just some symbols for how we know when to take one of these higher order derivatives. So this is our function. I'm just going to make a little chart. We've got the first derivative, second derivative, third derivative, fourth derivative, and if we keep going, we'll eventually come to the nth derivative, just some number n. So there are a couple different ways we can go. One is we start off with f of x, and this is what we were just doing up here. We have f prime of x, f double prime of x, f triple prime of x, and then we start doing numbers, f to the 4th of x, and then all the way down to f to the nth of x. It is in little tiny parentheses there. We can also write it like this, f of x, and then the derivative of f of x. And then the second derivative notation here is a little bit funky. It's a d squared over dx squared of f of x, and then d to the 3rd over dx cubed f of x. Here, I'll zoom in a little bit so you can see. And then d to the 4th over dx to the fourth, f of x, all the way down to d to the nth over dx to the nth, f of x. And if we start off with y, you'll notice something that's a little weird about this notation. So we've got y, we've got dy dx, we've seen that before. The second derivative is d squared y over dx squared. The squared is next to the d, and then the squared is next to the x. It's not next to the y up here. And the reason for that is basically we're saying we're taking the derivative twice with respect to x twice. When you're working with multiple variables, you might take something with the derivative with respect to x and then with respect to another variable at a different time. So this squared here just means we're doing it with respect to x both times. We're not going to see anything that's working with multiple variables at this point. So the third derivative, d cubed y over dx cubed. Fourth derivative, d4y over dx to the fourth, all the way down, d to the nth y over dx to the nth. Alternatively, we can also write the y's with the primes as well. So y prime, y double prime, y triple prime, y to the fourth, all the way down to y to the nth. Okay, let's look at some examples now. So find d squared y over dx squared, so that's the second derivative of y, if y equals 3x squared plus 4x minus 1. We're generally only going to go down to the second derivative, although like we saw up here we can keep going indefinitely if we want to. But this just means we're going to find the second derivative, means we're going to take the derivative of this and then take the derivative again. So let's start off with the first derivative, dy dx. We bring down the exponent, subtract 1, bring down the exponent, which is a 1, subtract 1, and then derivative of a number is just 0. And so with the second derivative, we just do that again. Derivative of this is 6, derivative of this is 0. And there we go. That's all there is to it. Sometimes when we're trying to take that second derivative, we're going to have to do a little bit more complicated algebra. So let's find the second derivative of f if f of x equals e to the 3x squared. So notice that this is a box function, so we're going to have to do the chain rule when we do this. So let's start off by doing the first derivative. So derivative of e to the box is e to the box times the derivative of the box. So we're going to have e to the 3x squared times the derivative of 3x squared. So this is where it's really, really important to make sure that you have this clearly labeled so you know what you're finding. So this was f of x, this is still f prime of x, that first derivative. Derivative of 3x squared is 2 times 3, which is 6x. Okay, so far so good, but now we need to take the derivative again. And now we'll notice that right here we have multiplication. So that means we're going to have to do the product rule. It's pretty common when you're doing the second derivative. You have to take some sort of funkier thing on the second time. So first we're going to do the derivative of e to the 3x squared, again, which we actually know what that is already, times 6x plus e to the 3x squared times the derivative of 6x. So the second derivative, well, here we have this. We actually already just found what it was. It's going to be this. But just for practice, let's work it out again. Remember, this is a box function, so we're going to have the derivative of e to the box, which is just e to the box, times the derivative of what was inside the box. This 6x is along for the ride. Derivative of 6x is just 6. It's e to the 3x squared times 6x times this other 6x plus 6 e to the 3x squared. And then I see I can factor out this from each term. Second derivative of x is 6e to the 3x squared. Left over here I have 6x squared plus 1. It is going to be really important for some of our later lessons to have this in factored form, so we might as well get used to it now. So that's the general idea of it. It's also entirely possible to be asked to find a number for the second derivative, just like sometimes we would be asked to find a number for the first derivative. So let's give an example of that. Instead of finding f double prime of x, let's find f double prime of pi. If f of x equals x cubed minus 2x squared plus cosine of x. So all this means is we're going to find the second derivative and then plug pi in for x. Make sure that you get all the way to the second derivative of f of x before plugging in that pi. So to get to the second derivative, we have to go through the first derivative. So we bring down the exponent, 3x squared minus 4x. The derivative of cosine is negative sine of x. So far so good. Now I do the second derivative, same deal again. Bring down that exponent, 6x minus 4, and then the derivative of negative sine is negative cosine. And there we go for that. Now we have to remember to take this pi and put it in for each of our x's. So the second derivative of f of pi is 6 pi minus 4 minus the cosine of pi. We'll figure out what that is right over here. So pi is right over there. It's negative 1 comma 0. Cosine of pi, that's the x coordinate, so that's negative 1. So second derivative of f of pi is 6 pi minus 4 minus negative 1. That ends up being positive 1, so our final answer 6 pi minus 3. Could turn that into a decimal if we had a calculator. Depending on whether or not you see that the multiple choice answer is written as a decimal or in a pi form, that would determine whether or not you changed this into a decimal.